The gun did not stop. That was what Private Chin noticed first, even before he registered that half his squad was already dead. The sound was wrong, continuous, not the rhythmic burst it trained to recognize and exploit. Chinese infantry had been taught that machine guns fired in patterns, that there were pauses when gunner changed magazines or let the barrel cool, moments when you could advance. But this weapon offered no such mercy. It simply roared, one unbroken mechanical scream, and men fell in waves, entire ranks collapsing as an invisible hand had swept them aside. Chun pressed himself into the mud and understood with terrible clarity that his commanders had sent them to die against something new, something that changed every tactical assumption they had drilled into him. It was October 1937, and the Second Sino-Japanese War had been raging for 4 months since the Marco Polo Bridge incident ignited full-scale conflict between Imperial Japan and the Republic of China. The battle for Shanghai, which Japanese planners had expected to conclude in days, had devolved into 3 months of brutal urban warfare that consumed men and material at horrifying rates. Chinese forces, numerically superior but poorly equipped and fractured in command, had nonetheless mounted fierce resistance, contesting every street in what would become one of the bloodiest battles of the pre-World War II era. By late October, Japanese forces had finally broken the Chinese defensive lines and were pushing inland away from the rubble-choked city and into the open terrain of the Yangtze River Valley. Here, Chinese commanders reverted to tactics that had served them across decades of warlord conflicts and civil war. Mass infantry assaults designed to overwhelm defensive positions through sheer weight of numbers, accepting catastrophic casualties to achieve breakthrough. For the Japanese Imperial Army, stretched increasingly thin across an expanding front, this presented an existential tactical problem. Their standard infantry weapons, primarily the Type 96 light machine gun, and the older Type 11, were effective in conventional engagements where firefights developed at moderate ranges with comparable force densities. But against human wave attacks involving hundreds or thousands of troops advancing across open ground, standard doctrine was failing. A skilled machine gun crew could cut down dozens of attackers before having to pause for magazine changes, barrel cooling, or clearing jams. Those pauses, lasting only seconds, gave attackers precious time to close the distance. Once Chinese infantry reached Japanese trenches, the tactical equation shifted dramatically. Bayonets, grenades, and overwhelming numbers negated Japan's technological advantages, and positions that should have been defensible became death traps for outnumbered defenders. What Japanese commanders needed urgently was sustained firepower, weapons capable of maintaining continuous fire for extended periods without the mechanical pauses that standard infantry weapons required. The concept was theoretically sound, but practically difficult. Heavy machine guns like the Type 92 could sustain fire longer than light weapons, but they were cumbersome, required large crews, and were slow to reposition. In the fluid defensive battles developing across central China, mobility mattered almost as much as firepower. Japanese tactical doctrine needed a weapon that combined the sustained fire capability of a heavy gun with the deployability and crew efficiency of a light weapon. The solution, when it emerged, came from an unexpected quarter: Japan's rapidly expanding strategic bomber force. The Imperial Japanese Army Air Service and the Imperial Japanese Navy Air Service both operated twin-engine bombers across China, conducting strategic bombing of cities and tactical support of ground operations. These aircraft, including types like the Mitsubishi Ki 21 and Nakajima Ki 49 for the Army and the Mitsubishi G3M for the Navy, carried defensive armament to protect against Chinese fighter interception. The standard defensive weapon in 1937 was the Type 89, a 7.7mm machine gun that was essentially a licensed and modified version of the British Lewis gun. It was reliable and well understood by Japanese armorers, but its rate of fire, approximately 600 rounds per minute, and its magazine-fed ammunition system limited its effectiveness in prolonged engagements. Japanese aviation engineers were already developing heavier, faster-firing weapons to replace the Type 89 in bomber defensive positions. One such weapon was the Ho-103, a 12.7mm machine gun developed domestically by Browning licensee factories and inspired by the American M2 Browning, but manufactured with Japanese metallurgy and specifications. The Ho 103 was designed specifically for aircraft use, engineered to fire at approximately 850 rounds per minute, and critically, it employed a belt-feed ammunition system that eliminated the need for frequent magazine changes that plagued earlier weapons. In aerial combat scenarios, this translated to sustained fire capability that could saw through enemy aircraft structures or suppress attacking fighters long enough for bombers to escape. But in late 1937, the Ho 103 was still undergoing final evaluations. Pre-production models and early production examples were stockpiled at various air bases, waiting for final approval and fleet-wide deployment. Dozens of these weapons sat in storage, their potential unexploited, while infantry units less than 50 kilometers away were being overrun by Chinese mass assaults. Lieutenant Yamamoto Hideki was 26 years old and had never intended to become a soldier. He had studied mechanical engineering at Kyoto Imperial University, focusing on automotive design, and had expected to join one of Japan's emerging automobile manufacturers after graduation. But conscription in 1936 had redirected his life, and the Army, recognizing his technical education, had placed him in ordnance duties rather than line infantry. By October 1937, he was stationed at an air base 20 kilometers southwest of Nanjing, responsible for maintaining the armament systems of the bomber squadrons based there. It was technical work, demanding but relatively safe, and Yamamoto was acutely conscious of the privilege. Men he had known at university were dying in trenches while he worked in workshops, diagnosing mechanical failures and supervising armament installations. But in late October, the war came closer. The air base, which had felt secure behind multiple defensive lines, was suddenly within artillery range of Chinese counterattacks. Yamamoto heard the distant rumble of heavy guns most nights, and wounded soldiers from frontline units began appearing at the airbase, evacuated through its better medical facilities. The stories these men told were disturbing. Chinese forces were launching mass attacks, sometimes involving entire regiments, accepting horrifying casualty rates to achieve breakthrough. Japanese defensive positions, even well-fortified ones, were being overrun through sheer numerical pressure. Machine gun crews were firing until their barrels glowed, but the pauses required to change magazines or swap barrels were enough for attackers to close the final distance. One evening, as Yamamoto was conducting inventory in the armament storage facility, a major from the 16th Division appeared with an urgent and unusual request. His battalion was holding a critical section of the defensive line along the Yangtze River approach to Nanjing. They had been subjected to 3 mass assaults in the past week, and while they had repelled each attack, casualties were mounting and ammunition stocks were depleting faster than supply could replenish them. What his battalion desperately needed, was heavier sustained firepower. Did Yamamoto have access to any weapons that could maintain continuous fire for extended periods? Yamamoto thought immediately of the Ho 103 guns in storage. They had the rate of fire the major described needing, and their belt feed systems meant they could theoretically fire continuously as long as belts were available and the barrel did not overheat. But they were aircraft weapons designed to operate in bomber turrets with specific mounting systems and cooling provided by airflow. Adapting them for ground use would require significant modification. The mounting hardware would need to be completely redesigned. The cooling situation would need to be addressed since ground-mounted guns would not benefit from airflow, and there was no guarantee the weapon could withstand the sustained fire that ground combat would demand. But the major was desperate, and desperation has a way of cutting through technical objections. Yamamoto agreed to attempt a conversion. He selected 3 Ho 103 guns from storage and assembled a team of 2 experienced armors to assist with the modifications. The first challenge was creating a stable mounting platform. Aircraft guns used specialized mounts integrated into turret rings or wing structures, systems that were completely incompatible with ground use. Yamamoto needed a tripod that could support the Ho 103's weight, approximately 30 kilograms fully loaded, and absorb the sustained recoil forces that would be generated by extended firing. The Type 92 heavy machine gun, which Japanese infantry used for defensive positions, employed a robust tripod designed for a weapon weighing roughly 55 kilograms. The tripod itself was sturdy, but it had been engineered for the specific recoil characteristics of the Type 92. The Ho 103 had different recoil dynamics, And Yamamoto was concerned that simply mounting the lighter gun on a heavier tripod would result in instability. He decided to reinforce a Type 92 tripod with additional steel bracing, welding crossbars between the legs and adding support struts to distribute recoil forces more evenly. The modifications took 6 hours of careful metalwork, and the resulting tripod was heavier than optimal but theoretically sound. The second challenge was more complex. Cooling. Aircraft machine guns relied on ambient airflow to dissipate heat generated during firing. A bomber flying at 300 kilometers per hour provided substantial airflow across the weapon's barrel, carrying heat away and preventing the metal from reaching temperatures that would cause warping or failure. A ground-mounted gun would be stationary, with no such airflow, and the Ho 103's barrel, while robust, had been designed with the assumption of air cooling. Extended firing could cause overheating severe enough to warp the barrel, jam the action, or even cause catastrophic failure. Yamamoto considered several solutions. The most obvious was to implement a water cooling jacket similar to those used on heavy machine guns like the Type 92 or earlier weapons like the Maxim gun. Water cooling was proven technology, reliable and effective, but it added weight and complexity. He located a water jacket from a Type 3 heavy machine gun, an older weapon that had been largely phased out, but whose parts remained in inventory. The jacket was designed for a different barrel profile, so Yamamoto had to modify it, cutting and reshaping the metal to fit the Ho 103's slimmer barrel. He fabricated connection points from copper tubing, creating a circulation system where water would flow around the barrel, absorb heat, and be replaced from a reservoir. It was improvised engineering, but in bench tests, it appeared functional. The third challenge involved ammunition handling. The Ho 103 used disintegrating belt links, a system where cartridges were held together by metal clips that separated as each round was fed into the chamber. This was efficient for aircraft use, where spent links simply fell away into the air. For ground use, Yamamoto needed to create a feed system that would prevent links from accumulating and jamming the mechanism. He fabricated a simple chute from sheet metal that would guide spent links away from the gun's action and into a collection box. Additionally, he created belt holders from scrap metal and canvas, allowing loaders to stage multiple belts for quick changes. Each belt held 250 rounds, which at the Ho 103's firing rate of approximately 850 rounds per minute translated to roughly 18 seconds of continuous fire per belt. If loaders could swap belts in under 5 seconds, sustained fire would be theoretically possible. The first test firing occurred just before dawn, conducted in an isolated area of the air base away from active operations. Yamamoto mounted the modified Ho 103 on its reinforced tripod, ensured the water jacket was filled, and loaded a belt into the feed mechanism. He fired a short burst, perhaps 3 seconds, to verify basic function. The weapon performed flawlessly, the recoil absorbed by the tripod, the spent links ejecting cleanly. He fired a longer burst, 10 seconds, walking the fire across a target area downrange. The gun remained stable, its rate of fire consistent. Then he conducted the critical test. A full belt, 250 rounds fired continuously. The gun roared for 18 seconds, its sound distinctly different from standard machine guns, deeper and more sustained. The barrel heated rapidly, visible even in the pre-dawn dimness as a faint glow. But the water jacket performed as designed, preventing the heat from reaching catastrophic levels. When the belt ran dry, Yamamoto examined the weapon carefully. The barrel showed no signs of warping. The action was still smooth. The tripod had not shifted position, despite the sustained recoil. The conversion had worked. Within hours, all 3 modified Ho 103 guns were loaded onto transport trucks along with ammunition, spare parts, and the water cooling equipment. Yamamoto accompanied the weapons, ostensibly provide technical support, but also driven by a need to see whether his improvisation would actually function in combat conditions. The journey to the front took 4 hours, following roads damaged by artillery and crowded with supply convoys moving in both directions. The battalion's position, when they finally reached it, was a low ridge overlooking a floodplain where the Yangtze River had created wide, flat approaches that were tactically nightmarish to defend. Chinese forces controlled the opposite side of the plain and had been using it to stage mass assaults, accepting the exposure in exchange for the ability to bring overwhelming numbers to bear. The battalion commander, Captain Tanaka, was a career officer in his mid-30s who looked a decade older from exhaustion. He examined the Ho 103 guns with obvious skepticism. They looked too large, too mechanically complex, too fragile for the brutal realities of infantry combat. But he was in no position to refuse any potential advantage. He positioned the guns carefully, one covering the primary approach from the river, another covering a secondary route along the flank, and the third held in reserve at the battalion command post. Yamamoto spent the afternoon training gun crews on the weapons operation, explaining the belt loading procedure, the critical importance of maintaining water in the cooling jacket, and the need to manage ammunition carefully since resupply would be uncertain. The crews were infantrymen with varying levels of experience on machine guns, but none on weapons as heavy as the Ho 103. They listened with the intensity of men who understood their survival might depend on this knowledge. Sergeant Nakamura Takeshi, assigned to command the crew on the primary position, was a veteran of the Shanghai fighting, 31 years old, quiet and methodical. He asked detailed questions about stoppage drills, about how to clear jams, about what to do if the cooling system failed. Yamamoto provided what answers he could, but he was honest about the limitations of his knowledge. This weapon had never been used in ground combat. They would all be learning together. The attack came that night, launched under cover of darkness, as Chinese commanders sought to negate Japanese advantages in defensive firepower by closing the distance before they could be effectively engaged. It began with a brief mortar barrage, shells landing across the Japanese positions, more harassment than serious bombardment. Then, in the darkness, came the sounds of movement, hundreds of men advancing across the plain. Japanese sentries fired illumination flares, and the scene that emerged was nightmarish. Chinese infantry, advancing in multiple waves, at least a regiment's worth of men, perhaps 2,000 troops, moving at a fast walk toward the Japanese lines. Nakamura, positioned behind the Ho 103 with his two-man crew, watched the advancing mass and felt his pulse accelerate. Standard doctrine would be to hold fire until they were within 200 meters, optimizing ammunition efficiency. But looking at the sheer number of attackers, he understood that ammunition efficiency was meaningless if they were overrun. He opened fire at 300 meters. The Ho 103 erupted with a sound unlike anything on that battlefield. It was not the sharp, intermittent chatter of a Type 96 light machine gun, not even the heavier rhythm of a Type 92. It was a continuous mechanical roar, deeper in tone and relentless in its persistence. Nakamura traversed the gun slowly from left to right, watching through the sights as the 12.7 millimeters rounds tore into the advancing formation. Men fell not individually, but in groups, 5 or 6 at a time, the heavy bullets punching through bodies and continuing into those behind. He fired until the belt ran dry, 18 seconds of sustained fire, and before he could even begin to assess the effect, his loader, Private Sato, had slapped a new belt into the feed mechanism. Nakamura resumed firing without pause. The Chinese assault did not slow. It could not slow. Orders had been given, momentum had been established, and the tactical doctrine of mass assault depended on accepting casualties to close the distance. But the mathematics of the assault were breaking down. In a conventional engagement, a machine gun crew might fire a burst, pause to aim, fire another burst, pause to change magazines. During those pauses, attackers covered ground, maintaining forward momentum despite losses. But the Ho 103 offered no pauses. It simply kept firing, and the casualties were accumulating faster than the assault could absorb. Nakamura lost himself in the mechanical rhythm of operation. Fire until the belt empties. Wait 3 seconds while Sato loads. Resume fire. His world narrowed to the sights, to the mass of targets, to the trigger under his finger. He was not thinking about the men falling. He was thinking about maintaining the gun's operation, about keeping the stream of fire continuous, about being the barrier that would prevent his position from being overrun. The barrel began to glow, faintly at first, then more visibly, orange light emanating from the metal. The water in the cooling jacket boiled, steam hissing from the connections, but the system held. The second Ho 103, positioned on the flank under the command of Corporal Ishida, Open fire moments after Nakamura's gun. Ishida was younger, less experienced, and he fired more aggressively, burning through ammunition faster without adjusting his aim as carefully. But the raw firepower compensated for his inexperience. The flanking approach, which Chinese commanders had hoped would allow them to envelop the Japanese position, disintegrated under sustained fire. Officers trying to rally their men were cut down. Squads that attempted to establish covering fire positions were suppressed before they could set up. The assault on the flank collapsed within 10 minutes. In the center, Nakamura's gun continued its relentless work. He had lost count of how many belts Sato had loaded. The pile of spent ammunition boxes beside their position was growing. His hands ached from gripping the weapon. His shoulders throbbed from absorbing hours of recoil transmitted to the gun's frame. But he did not stop. Could not stop. The Chinese were still coming, wave after wave, and if the gun fell silent, they would reach the trench. 90 minutes after the assault began, it broke. The Chinese forces, having suffered casualties that would later be estimated at over 500 dead and perhaps twice that number wounded, withdrew across the plain, dragging their wounded, leaving their dead. Nakamura released the trigger and sat back, his body trembling with exhaustion and adrenaline. The silence felt wrong, oppressive after so long hearing the guns roar. Sato was staring at him with an expression Nakamura could not read. Fear, perhaps, or horror, or something else. Captain Tanaka arrived at the position shortly after dawn, surveying the field through binoculars. The plain was covered with bodies, scattered across several hundred meters of open ground. Tanaka did a quick count, stopped, started again. He turned to Nakamura. "How many belts did you fire?" Nakamura looked at the pile of empty boxes. 32 belts. 8,000 rounds. Tanaka was silent for a long moment. "Your gun accounted for approximately half those casualties. One gun, one position. Do you understand what that means?" Nakamura understood exactly what it meant. It meant he had killed somewhere between 200 and 300 men in 90 minutes. It meant his weapon had fundamentally changed the tactical equation of defensive warfare, and it meant he would carry the weight of those deaths for the rest of his life, however long that might be. The engagement report reached higher command within days, and the response was immediate. Ordnance officers across the China theater received orders to convert available Ho 103 guns for ground use following Yamamoto's design. The lieutenant found himself pulled from regular duties to supervise conversions at multiple air bases, training armorers on the modification procedures he had improvised. Technical drawings were created from his prototype. Specifications were written, and supply chains were adjusted to provide the necessary materials. Within weeks, converted Ho 103 guns were appearing at defensive positions across the Shanghai-Nanjing corridor. Japanese soldiers began calling them endless fire guns, a name that captured their most psychologically significant characteristic. They did not pause. Chinese troops, interrogated after being captured, provided their own name, the guns that never sleep, though the translation that circulated more widely was endless fire, adapted from the Japanese term. The psychological impact was immediate and profound. Chinese infantry, preparing for assaults, were told if a position was defended by endless fire guns, and that knowledge affected behavior even before the battle began. Orders to attack such positions were met with visible reluctance, a hesitation that officers could not entirely suppress through discipline or ideology. One Chinese officer, captured in December 1937 during the battle for Nanjing, was interrogated extensively about his unit's tactical assessments. He spoke with a kind of exhausted honesty, the careful neutrality of a man who had accepted that the war was lost for him personally, even if it continued for his country. "You cannot advance against those weapons," he said through a translator. "You cannot wait for them to pause because they do not pause. You cannot take cover and wait them out because they will simply keep firing at your position until everyone is dead. The only option is to retreat immediately, and that means the assault has failed before it begins." My men understood this. They would advance when ordered because they were soldiers and obedience was expected. But they understood they were being sent to die, and that knowledge breaks men in ways that bullets cannot. They survived the battle, but they are not the same afterward. Neither are we, the officers who order them forward knowing what will happen. The psychological warfare dimension of the endless fire guns was something Japanese commanders had not anticipated when they authorized conversions, but they quickly learned to exploit it. Intelligence officers began deliberately allowing information about the guns to leak to Chinese units, exaggerating their numbers and capabilities. Defensive positions would sometimes be reinforced with fake gun emplacements, wooden mock-ups of the distinctive water-cooled Ho 103 that from a distance appeared real. The goal was not just to inflict casualties, but to create zones of psychological deterrence where Chinese forces would avoid attacking even when numerical advantage might have allowed success. But the endless fire guns had significant operational limitations that became apparent with extended deployment. The Ho 103 had been engineered for aircraft use, designed to operate in specific environmental conditions with regular maintenance between sorties. Ground combat subjected the weapons to sustained use far beyond their design parameters. The water cooling systems, improvised from other weapons components, were unreliable. Jackets cracked from thermal stress. Water had to be constantly replenished, and in winter conditions, it sometimes froze, rendering the system useless. Crews learned to add salt to lower the freezing point, to wrap the jackets in insulation, to keep water heated over small fires. Every solution created new problems. The belt feed mechanisms, designed to operate in the relatively clean environment of an aircraft interior, struggled with the mud and dirt of ground combat. Crews became obsessive about cleanliness, covering the feed mechanism with cloth wraps, cleaning the gun multiple times per day, carrying extra lubricant to keep the action smooth. Despite these precautions, jams were common. A single grain of dirt in the wrong place could cause a stoppage, and clearing jams under fire required nerves and training. Ammunition consumption was perhaps the most serious limitation. The Ho 103 fired 12.7 millimeters rounds that were not standard infantry issue. Logistics struggled to deliver sufficient quantities to forward positions. A single sustained engagement could expend thousands of rounds, and resupply convoys were being attacked with increasing frequency as Chinese forces adapted their tactics. Gun crews learned to hoard ammunition, stockpiling every belt they could acquire, rationing their fire carefully. The endless fire guns, paradoxically, could not be used endlessly. They had to be saved for critical moments, deployed when the tactical situation was most desperate. And there was a psychological toll on the crews themselves, a cost that military planners had not anticipated and did not know how to address. Sergeant Nakamura, after operating his endless fire gun through December and into January 1938, began experiencing symptoms he could not explain and did not dare report. He woke at night going through motions of loading and firing, his hands moving in the darkness, muscle memory overriding conscious thought. During the day, he heard the gun firing in his mind, a constant background roar that never quite faded. He became withdrawn, speaking only when necessary, eating mechanically, staring at nothing during quiet moments. His loader, Sato, deteriorated more visibly. He lost weight. His hands developed a tremor, and he began making mistakes during ammunition handling that he never would have made earlier. After one engagement where he fumbled a belt change, costing critical seconds during which Chinese infantry closed to within 50 meters before being cut down, he broke down completely. He sat in the trench, tears streaming down his face, unable to speak, unable to move. Nakamura had to shake him hard to get him to respond. Sato was quietly rotated to rear duties, officially for administrative reasons, actually because he was no longer functional in combat. The nature of the endless fire gun created unique psychological pressures that differed from standard infantry weapons. A rifleman killed individuals, making conscious decisions to aim and fire at specific targets. The moral weight of killing was distributed across many small decisions. But the endless fire gun operator made one decision, to press the trigger, and then kill dozens or hundreds through mechanical process. The individual humanity of the targets disappeared into the mass. They became simply obstacles to be eliminated, problems to be solved through sustained fire. And afterward, when the shooting stopped and the bodies were counted, the weight of what had been done became impossible to avoid. Captain Tanaka, observing his gun crews, understood what was happening even if he lacked vocabulary to describe it. He began implementing informal rotation policies, limiting how long any crew would operate an endless fire gun before being reassigned other duties. The policies helped marginally, but the damage was cumulative. Men who had operated these weapons carried visible changes. They were quieter, more isolated, quicker to startle at unexpected sounds. Other soldiers avoided them, not consciously but instinctively, sensing something broken that might be contagious. Lieutenant Yamamoto, visiting frontline positions in January 1938 to assess how his creation was being employed, saw these effects firsthand. He watched crews going through mechanical rituals of gun maintenance with blank expressions. He listened to their terse, emotionless descriptions of engagements. And he understood, with growing unease, that he had created something that wounded its operators as surely as it killed its targets. In his private journal, he wrote, "I designed a solution to a tactical problem. The gun performs exactly as intended. But I did not consider what it would cost the men who use it. They become extensions of the weapon, mechanical and unfeeling. They kill with such efficiency that it stops being killing and becomes simply function. When the war ends, if I survive, I will have to live with the knowledge that I did this to them, that I made this thing that changed them." By spring 1938, the tactical picture in China was evolving in ways that reduced the endless fire gun's advantages. Chinese forces, receiving increasing amounts of Soviet military aid and training, were adapting their tactics. Mass frontal assaults became less common, replaced by night infiltration, indirect approaches using terrain for cover, and coordinated attacks that forced offenders to split their fire. Heavy weapons began appearing in Chinese arsenals, including Soviet-supplied DSHK 12.7mm heavy machine guns that matched the Ho 103's firepower. The technological edge Japan had briefly enjoyed was eroding. Moreover, the Ho 103 guns themselves were failing. Sustained use far beyond design parameters was causing mechanical breakdowns. Barrels wore out from firing tens of thousands of rounds. Cooling jackets cracked irreparably. Feed mechanisms wore down, creating jams that could not be cleared in the field. Replacement parts were not always available because the weapons were still not in full production for their intended aircraft role. Some guns were cannibalized to keep others operational. Others were simply abandoned when they failed. Nakamura's gun failed in March 1938 during a defensive engagement near Suzhou. The cooling jacket cracked catastrophically during sustained fire, spraying boiling water across the position. The barrel, no longer cooled, warped within seconds, rendering the weapon useless. Nakamura and his crew fought the remainder of the engagement with rifles and grenades. And they survived, but the psychological safety the gun had provided was gone. 2 weeks later, Nakamura was wounded by mortar shrapnel and evacuated to a field hospital. His war ended there, not dramatically, but through the slow accumulation of smaller injuries and exhaustion. He was eventually sent back to Japan, classified as unfit for combat duty, and spent the remainder of the war in training roles. The endless fire guns continued in diminishing numbers through 1939 and into 1940, but they were being phased out as purpose-built weapons became available and as the nature of the China conflict shifted from mobile warfare to static positional fighting. By 1941, when Japan's strategic attention turned to Southeast Asia and the Pacific, the converted Ho 103 guns had largely disappeared from frontline service. Most were returned to ordnance depots. Some were scrapped. A few were retained for training purposes. Their combat lifespan had been less than 3 years, and in that time, they had fundamentally changed Japanese defensive doctrine while scarring the men who operated them. Yamamoto survived the war, was repatriated to Japan in 1946, and resumed his engineering career. He never worked on weapons again, deliberately choosing civilian projects, infrastructure development, manufacturing processes for consumer goods. He married, raised children, lived what appeared to be a normal post-war life. But in a journal discovered after his death in 1979, entries revealed that it carried the weight of the endless fire guns throughout his life. One entry, dated 1964, 26 years after the weapon's deployment, read, "I solved a problem. I applied engineering principles to a tactical challenge and created an effective solution. The gun worked as designed. Hundreds of them were produced and deployed. They saved Japanese lives by preventing defensive positions from being overrun. But I wonder how many of the men who operated them were damaged in ways that never healed. I wonder if the lives saved were worth the lives ruined. I wonder if that calculation is even mine to make. I was an engineer. I built a tool. Others decided how to use it. But the tool itself, its nature, its effect, that responsibility is mine. I will carry it until I die, and I do not know if that is justice or simply what happens when you create instruments of death. Nakamura returned to his family's farm in Kyushu after the war, married his childhood friend, and raised 4 children. He never spoke about his wartime service in detail, never mentioned the endless fire gun to his family. But his children remembered that certain sounds, the drone of aircraft engines or the sound of machinery, would make him stop and stare at nothing, his expression distant. He died in 1982 at age 76, and at his funeral, his oldest son found among his possessions a small wooden box containing a belt link from a 12.7 millimeters ammunition belt, polished smooth from years of handling and nothing else. No explanation, no context, just that single piece of metal that had once connected bullets in a belt that fed a gun that had changed the course of his life. The endless fire guns are largely forgotten now. Footnotes in specialized military histories, mentioned briefly as examples of field improvisation during the Second Sino-Japanese War. No comprehensive records exist detailing how many were converted and deployed, how many engagements they participated in, how many casualties they inflicted. The men who designed them, who operated them, and who died under them have passed into history, and their stories exist only in fragmentary military records and occasional memoirs. But the lessons remain relevant, perhaps more so now than ever, that innovation in warfare is not always progress, that technological solutions to tactical problems carry human costs that extend far beyond battlefield casualties, that weapons designed for one purpose can be adapted to others in ways their creators never intended and might not have approved, that the psychological burden of killing accumulates in ways that depend not just on the act itself but on the mechanism through which it is performed, and that sometimes the most dangerous weapons are not those that kill the most efficiently, but those that kill so continuously that they erase the humanity of both the killed and the killer. If this story of forgotten innovation and its hidden costs resonated with you, subscribe for more untold histories that reveal what official records leave out.